For those of you coming in or been here for a while, the slides are already online. If you want to follow along on your phone or on your tablet, they're good to go there. They're HTML based, so easy to load up. All right, let's get full screen here. All right. So, this is Exploring PROC with Friends. This is the room you're looking for. Good, you're in our room. If not, good luck getting out of here. There's not even a way to get out of here. So, you're stuck. Awesome. Happy little mistakes here. All right. So, before we get started, real quick, a couple slides up here that I feel are super important. First off, hello. My name is Alex. And I hope that you all come up and say hello at the presentation. I think sometimes people jump into presentations and don't start with hello, right? Also, especially with the number of people in this room, thank you. There are a lot of presentations going on right now, and so I'm truly humbled and honored that you choose to spend time with me today and this topic. All right, those are out of the way. On with the show. Today's agenda. We're going to do, first off, why this topic? As you all know in the title, this is talk about PROC. So why a topic from, essentially the early 80s or mid 80s, okay? It's not a doctor talk, it's not a new talk, it's an old talk, it's a back to basics talk. Then we'll go through my favorite interview question because it has to do with PROC and it gets a demo up front and out of the way. Usually I do demos at the end, try something different this time. Hopefully a demo can relate to some of y'all, give you some more questions to ask, some more thoughts to ponder about PROC as we go through that setup. And then we'll talk about what the PROC file system is. Then we'll talk about different parts of the PROC file system. We'll talk about, I'm gonna keep doing this. We'll talk about system-wide PROC files, things that pertain to your whole system. And then we'll jump into the PROC file system that pertains to just individual PIDs and talk about those individual files there. I won't cover all the files. I'll cover files that I find important to myself and to the people I work with every day as a system administrator working frontline support. And then last at the end, we'll talk about interacting with PROC, what we can change, what we can tune, what knowledge we can twist and turn. And then lastly, we'll do some extra stuff. We'll see how much time we have when we get to that point, how much we do. All right. If you guys have questions along the way, raise your hand. I'll try to recognize you, and we'll go have a conversation about it, right? This is not super formal. If you have questions, we'll have answers, or we'll find some, and we'll talk about it. So, first off, why this topic? History first. So, real quick bit of history, just so we set the stage for where we came from, where we're at now. So, like I said earlier, the PROC talk here is a technology from the early 80s. First showed up in Unix, the 8th edition, in 1984. Okay, I was 1 year old. Yeah. In 1992, Plan 9, an operating system out of Bell Laboratories. So actually, back up here. When it first came out, PROC was one file per process. Okay, one file per process. Very flat structure. In 1992, when Plan 9 decided to restructure the layout, that's where you get the one directory per PID. So that you get to see the layout a bit more in depth. At that same time, Solaris and Linux began to follow suit on that. And then I cannot find, so this was in Wikipedia right here, 1996, full implementation. I cannot find other citations for it, so if anybody here can tell me exactly when it was fully implemented, that'd be awesome. But that's what I found on Wikipedia right there. So that one, I'm going to put a little star next to it, say, not quite sure on that date. I do know, looking at the man page, the earliest reference to PROC is 2.0 kernel, so right around there. Okay, so I'm really not a big quote person, but this one kind of struck me for a talk like this, where it's a back to basics talk. Knowing is not understanding. There's a great difference between knowing and understanding. You can know a lot about something and not really understand it. In my field, working with system administrators who deal everything between, the base OS to, the hot new stack that either would be Elk or Apache or LAMP or anything out there, right? It doesn't really matter. We're going to get questions on it. So I have a lot of techs that know a little bit about a lot of things. And in our environment, it's a managed hosting environment. So what that means is that every customer there has a chance to run their own environment the way they see fit. So some people have a full stack for monitoring their environment. Some people have a Java app that's 10 years old. And we need to help everybody between both places. So I take these talks for something like PROC and strace or other base technologies where no matter what server you're on, no matter what environment you get into, you'll be able to begin to troubleshoot, see what's going on. Really, it's about understanding where your tools are getting their data from, and how you can begin to use that in your own tools and your own setup. Really, just understand where it's coming from. Okay. So again, this is really a back to basics talk, if anything else. So, my favorite Linux interview question. On top of mentoring, training, and full classes where I teach week-long classes, I do a lot of interviews. And so my favorite question begins something like this. We're setting the scene here. We're working on a configuration, and you accidentally delete a number of open files or open log files currently in use. I make note of that, open log files. Okay, I'm trying to guide the candidate towards some answer, and it's my favorite question. For a big reason here is that rarely anybody gets the answer correct. I'm not trying to set up a failure. One of my goals in doing these talks, in doing interviews, in doing any type of teaching or mentoring is to entertain you long enough to learn something. So this question isn't to set them up for failure, it's to see if they can find a way towards an answer, or we're going to walk away with a little more than they came with. They're going to learn something, okay? So, but when someone does have the answer, I've probably done interviews for the last 5-6 years, I guess, or so. And I've had 2 people come with the answer to that previous scenario, right? There's always a story behind why they know the answer to the question. Usually it starts with, so I deleted something. Something went wrong. Something crashed. Right? So I want to walk through the answer to that topic, that question of, right, I've deleted log files that I need to get back. I think they're open, so I want to try and see if I can get them back. So let's go over to here. Demo time, or put up their clobbering time, because if anybody's seen me type one-on-one, I'm a horrible typer. Now with this many eyes, it's going to get bad. So let's find out. That's why my backspace button's like it's clobbering time. All right, so simple box here. Let's see, we have cat, let's see, issue. Not sure, Red Hat release. What am I on? See, it's already happening. CentOS 6.7. Okay, just kind of get a base of where we're working out right now. Okay. The classic example is, let's see here, do I have Apache running? I do. Okay. All right. So let's say I'm in var log HTTPD. What I'm going to do real quick here, just to make sure that there's no trickery happening, even though it is Linux, it's all trickery. I'm going to go ahead and do an MD5 sum, just so we have a base of what that file should resolve to, right? The hash should resolve to. It's MD5 sum access log. We're going to put that into, let's see, temp, and then we'll say pre dot access MD5, something simple like that. All right, and we'll cat it out, make sure we have the right thing here. Okay, this is all set up for where we're going to use PROC to do some magic here. All right, because it's there, RAM access log. Okay, so and this is the case of scenario where I've deleted a log file that I need to get back. So ls, no. And so when I give the candidate the option, I say, hey, that file is probably open. What's your next step? Well, you delete the file, it's gone. It's usually the first answer. Well, so that helps me get a gauge on where their mind's going. I say, well, is there a way you can see what files are open? If we think it's open, how do we check that? There's a command that can do that, lsof, list open files. Okay, just real quick here, click the screen. Gives me a ton of files. That's not pretty. Can we do a little easier? That's better. Yeah, okay. So list of open files. It gives me a list of all the open files we have. Now I don't care so much about that. I know that I deleted an Apache file. And so let's go ahead and sof -u Apache and just normalize it to just those users. Is it up?
You can't see that.
All right. Let me see if I can bring it down a little bit here. Yeah. Thank you. All right. So, a lot of files. These are all the files that Apache has open at this point. But this one here is the one I care about. Okay. Tells me that it has a file open, but it's been deleted. So, application knows it has it open, but it also knows it's been deleted. If If I restarted Apache right now, that file would be gone for all easy purposes. Okay? Technically, we can get back, but it's a different conversation. So we go through this conversation where we say, hey, so if you have this output, what do you see there? All right, what we see here is that we have the name of the process, the PID, right, the owner of it, and then this right here is what I care about, 7W. That column right there, if I can do this real quick, LSOF, type head 1, is the file descriptor. Those match up correctly. Okay. If I run any command up here that you're curious about, I don't explain it, let me know. Down right there, I'm just pulling the top line from the output there. I've been known to throw a lot on the screen and not explain it, so call me on it. Okay. But what I care about here is this file descriptor, 7W. What that tells me, it tells me the file descriptor that this belongs to and how it was opened for write or for read or for updates, any of those things. But it tells me something. Because I'm familiar with PROC, I can go to PROC, a PID, and we see in there a number of files. And we'll go through some of these files later on, but I want to talk a little more towards this demo here. In there we see the FD directory, or file descriptor. What's going there? Clear screen so you can see up there a little easier for everybody. ls. Okay, well, that's great, but ls-lah. See what we have here. That number there corresponds to the file descriptors within PROC. Okay? So that tells me, hey, that's the file I want. There's still pointed to it somewhere held open. Copy 7 to temp, and we'll say deleted log. Okay. Well, that's good. Let's go take a look at temp. We have our deleted log there. Let's cat that out. Do we have anything in there? We do. Okay. Real quick, MD5 sum 4, deleted log. 7CE3, hard one to say. Root, what do we have here? We have our, did I put in temp? I did, right? Yeah, there we go. Thank you. Cat pre, MD5, as the same file that we deleted.
Question?
Yes?
Does that rely on the inodes not being harvested yet?
Exactly. That's exactly what that is, right? And actually, I've only had 2 people come with that train of thought, but it shows an understanding of the whole process of when you delete a file, what happens, right? You want to link that inode, that's good, but the pointer's still there, the data's still there, right? No, if this happened maybe 2 weeks later, then yeah, maybe we have a problem. But right away, I've made a mistake. Oh no, we can do that, right? Question.
So that file, from the perspective of CP, that file that you just copied from procpid FD, that is basically a hard link, right?
Yeah.
From the perspective of CP.
Well, so in the PROC, it's a symbolic link. So, but it copies out from that pointer to where it was, essentially. Make sense? Yeah.
Say that again?
It copies out from the pointer for the original pointer where it had opened that the pointer to that file location, right, on disk. It's pointed from there, not necessarily a hard link to it. If we go into PROC, those are all symlinks essentially.
Symlinks to.
So, well, to the original location of that file. I'm not sure the right term for that. Let me get back in the directory here real quick.
You're right, it is a hard link because you're getting to an inode. And hard links are just links to inodes.
Okay, yeah. In that case, yeah. Let me go back in there real quick.
I'll just put stat on 7.
Mirror stat 7. Where'd it go? Symbolic. That's where I was pulling symbolic link from.
So link count didn't increment, so it's not a hard link.
Yeah. So like I said, by 5 years of interviewing people, 2 people have come up with the answer. Usually because something horribly went wrong, and that's how they know. That's how they did the research to find that out. So that's my demo up there. So hopefully that kind of gives you an idea of what we can do with PROC off the bat. But now we're going to step back and go back to the slides and kind of go through a few more things. So, any more questions on this quick demo? Yes?
If that's a symlink, how, like, it's pointing to this path that has deleted at the end, and how does that work in terms of copying out?
Magic.
Magic, okay.
I would say all things magic. I don't know.
Okay.
I will say that. Right? It's FM. Don't ask what FM stands for. All right. Cool. Real quick, any other questions? One more.
Yeah, on its face, is that not a bug?
I don't know. I haven't read what
Deleted
the.
the file.
I unlinked the inode.
No, when you delete a file, you're just removing a link to an inode. This is not Windows.
so when I delete the file, like I said, the link to and directly the link to that file has been removed. The actual data is not gone. Right? It won't be gone until it's overwritten or you shred or something like that to actually overwrite that data. So
This only works because the file's open and Apache's still capable of writing to it.
Correct.
If Apache writes a new log, it would still write to the one he copied to /10.
yeah, if I restart Apache, all this would be gone. All this wouldn't. Only because I have it open still. That this trick works. Yeah. Yeah. Question there?
Is there a size limitation for something like that?
I have not hit one yet. I have pulled over a gig out. My example was I was. Here's my personal story of why I know this. Right. So I was working with a customer, and they wanted to have certain users have access to logs, and we ended up going through a bunch of options, but in the end we ended up chrooting their home directories because they didn't want access to logs, only access to logs, but not access to nothing else. That's fine. So at the time, what seemed the best idea was to do a bind mount for var log into the home directories, so they had that in their chroot. Well, I got it working. I was super happy. They was set up automatically. I run a script. It works. Super happy. rm-rf the home directory. Yep. After a quick call to MBU to restore everything else, that's when I started pulling these. I pulled Apache's log, RSys log. I pulled MySQL's log out. All stuff that like real quick from there. Called the customer and said, "Hey, I am very, very sorry. I've saved these logs. The rest are on their way. Can I restart and put everything back in place?" Like, sure. Thanks for calling us. All I cared about that I told them what had happened. So that was my mistake of having that bind mount in there and just removing the whole thing. So I was so excited that it worked that I broke it. So.
It works on much larger files. I had a guy do rmrf /VMs on a hypervisor. Works on multiple terabytes.
I like this. All right.
Really, it's just as simple as unlooking the inode.
Yeah.
It's all.
Yeah. It should just be a pointer to that location, yeah. All right. So what is the PROC file system? Keep the questions coming, guys. I really do like this. I like to have this conversation as opposed to just me yammering on at y'all. So, /proc is a pseudo file system that acts as an interface to the kernel. What this means is it's a runtime file system that gives us an idea of what's happening in the kernel. It also gives us a chance to change some of the tunables, but they'll talk about that later on. But in kind of just the grand scheme of it all, pseudo file system, a virtual file system. In other words, it's not real. You turn your box off and it goes away, right? This is a runtime file system, okay? I had tech one time look at our exclusions for backups, to do backups for a file system. And there was /proc on the exclusions, and they asked why. And I would tell them, it's not real. They didn't get it. So if you're still not buying this, that's not a real file system, a couple things I'm going to kind of show it's kind of unique about /proc. They're all virtual files, and that's fine. But what we'll see here is, real quick, is that these files, and those not familiar with watch just runs the same command over and over and over. But these files, we have a zero size, are constantly being updated, constantly being their access time all updated, right? And we can cat that file out. There's stuff in it. Again, it's just a virtual file. All things I've used to try to explain to people that PROC's not real. So maybe a better name for this talk is PROC's not real. All right, so and then also, bless you. Go into PROC. We see that we have a ton of 0-byte files. Okay, right. Not real, but if we do something like any of these, they have something in them, obviously. Right? Okay, so the top level PROC files. I'm gonna go over some of the ones again I've found useful and why I found them useful. Again, these all come from, if you will, war stories on the floor, support floor, for the last 9 years or so. some of these are the most basic ones. I meant this to be an introduction, exploring PROC with friends. Maybe you can yell your favorite ones when we get to the end of this section. So, some of the more useful top-level files. Cat proc command line. Okay. Useful when we need to know if the kernel or the kernel parameters we added in grub.com for wherever that might be took effect. Right? I've had customers a couple times say, I changed this file, they're not in effect. Would you reboot? I don't remember. We cat this out and say, oh, you didn't do it. You need to still reboot. Okay. So stuff like that here. Let's see here. It's hard to view up there, so I'll hop back on the screen and kind of get a bigger view of that. For there. Oh. Cat. Command line. Okay. In the root in the /proc directory, that gives me again all the kernel, how it was loaded, all the options for it. Okay. I'm gonna switch back and forth a lot from the slides to the terminal just because it's hard to read on the screen. Mainly more as a reference point when you go back and look at it later on. Okay. CPUINFO. Okay. Useful when in our environments where we're deploying our boxes, and we need to make sure that what was ordered is what was delivered, right? That because the machines are made by our DC techs, so mistakes can happen. It's very rare, but they can happen. So make sure that what matches our internal reporting is what we have on the box itself. Also, lets us know what flags are available to our system itself. We want to make sure that we can do virtualization, things like that here. All right. If you want to make sure you can do cloud on cloud on cloud, check that right there, right on your VM. All right. That's a bigger picture of what we just showed you. So we'll skip that one. Load average. All right, this one's fun. One of the things that encouraged this talk was to talk about the number of tools that this is where they get the information from. Right? There's so many tools out there that all they're pulling from is PROC. Okay? Anything that shows you load average is pulling from cat proc load average, or I keep saying cat, but PROC load average, right? Gives your first, your 1, your 5, and your 15-minute averages, and your first 3 right there. These two are kind of nice, or interesting. I usually don't see them too much. The first one, that 1/99, is not problems. It is the number of. Thank you.
This is good. I like
I had Beyonce reference once and no one laughed. It was horrible. So it is the number of processes actually using CPU time at that kind of instance, which makes sense. We have that one cat process going out there. And the 99 is the number of processes that could be contention for CPU time. That first number shouldn't be, I wouldn't say it never be because, bugs and stuff. Shouldn't be higher than the number of processors you actually do have, right? Because you need CPU to run a process that shouldn't be higher. The last number there is the last PID issued. Okay. So on a very slow and boring box like mine, these numbers should go up incrementally. If they didn't, I'd be worried. Question?
Where is that documented?
That is under man proc. We're going to.
I know about that. Each individual file has a format, and they're pretty obscure.
Yeah.
Each individual file is documented in that man page?
Quite a bit of them are. I've yet to find one that's maybe a few that are not, but
Good.
most of what I've gone through is here. Usually what I'm doing is, where am I doing it? Load average. Yeah. So yeah, I remember it didn't used to be this good. It used to be a lot worse.
A lot of tribal knowledge.
Yeah, it was a lot of tribal knowledge. I've spent many times looking through kernel documentation. I'm not sure what versions got better in, but it has gotten better very recently. Yeah.
kernel documentation is your best bet.
Yeah. All right, up to see here. Some of the sys stuff, some of the proc sys stuff wasn't in there, but I think all of the top level proc stuff was that I was going through at least. All right, is that what we got? Yeah. Okay. Cool. Keep questions coming. All right, exploring the PID forest. Right, each process has its own happy little story. So we've at this point now we've talked about. Right, all of these files at kind of that top level information. There's a ton more files up there we can go through. towards the end, we'll go through some of the programs that use some of these files in particular, where does it go? I'm missing it. Like vmstat and iomem. But what we're going to talk about now is all the directories in here, all these number directories. All these number directories represent the PIDs on the system. Okay. Let's see here. The classic demo we do with new admins to kind of tie it all together for them is cat proc 1. That first one is command line. Tells us what the first one is. Because it's still 6, it is still a init. If this was 7, it would not be a init. It would be systemd, followed by a ton of flags or arguments. Okay, so what we're going to do now is go look at these individual directories here. Again, yeah, this was a major change from the original implementation, was that every single process now has its own directory under PID and not just one large file. Okay. All right, so I already shown that one here. Proc PID command line, useful for how the command was called. Also, if you do command line, it's not what you expect, something's up, right? Something might be up. A lot of this stuff comes from troubleshooting boxes that have been compromised, trying to figure out where it came from, right? If you do that and you expect a patching and it says Perl, something's up, right?
This is just my OCD. Did you restore that file?
Thank you. I did not restore it. I put it back into temp. That's why I did MD5. So
Okay.
Yeah. It's still there, right?
Okay.
Let's not restore Apache. But yes, thank you.
Okay.
All right. This was an interesting one. So cat proc, the PID, and then the environment variables. Let's see here. Let's go into. Let's grab one of these. I'll explain that one later on for those not familiar. Proc here, and then CD. That's not the right command at all. That's not pretty. Let's change that. I can change that. Where'd you go? All right. Well, let's go with that for now. This file here gives me the environment variables that process is running with. Anybody ever have cron run incorrectly because of path, right? The variables weren't there, right? Because cron runs in a different environment. That's a way to figure it out, right? That's a way to say, hey, what environment variables do I have? Okay, am I sourcing the right things? What does that process's world look like? Because that process, that's its world. That's what it's running with. Okay? The classic example is cron not running correctly because it doesn't have the right path, hasn't the right source correctly, things like that. Let's see here.
What's the underscore?
Where?
Yeah.
Right here?
Yeah.
I do not know. Lang equals CS. I need to look that up.
Like I know it shows up.
I want to say that's the last command.
What if you just echo $?
That's the last command, yeah.
So maybe it's
Last command.
the last argument of the last command?
Previous directory?
Yeah, I think it's argument.
Oh, yeah, looking at that.
Command bash.
We're not doing that one here. PID. All right, and then coming back to, because I find it super useful, is where we go back here. Let's do 22. Why not? FD proc 22 FD. I have no idea what this one is, but oh, no files there. That's great. Let's grab that. Right, like we saw earlier. All different files, or we'll say files, right? For Apache there, right? Because in Linux, everything's a file. Okay, I'm on time. Okay. All right, these are fun. I'm highlighting these because these have become a bane of some of our existence. at least for our environment. Anybody have a process killed by a memory killer? Anybody run on memory ever? Yeah? A few people? Okay. For us, the first thing we kill off with SSH usually. We work remote. The DC's in a different city. We have access to those boxes. Why SSH die off soon? So we try to make sure that it's one of the last things it kills off, right? Some customers might go in and say, you know what, I don't care how long it's bad, whatever's running, never kill my Java, right? Never kill my Java. This is one of the few values you can modify per process. Okay? The OOM, or out of memory adjustment, and the OOM out of memory score. The adjustment is like your nice value. It's your value you're kind of throwing to it and say, hey, give it a better chance, give it a fighting chance. The score is what the OS thinks its score is to be killed off. So much like priority and niceness, you can influence the adjusted score. The niceness can be, or you can influence the adjustment. The score is going to be determined by the OS itself, or the kernel itself. Okay, it goes. I put the note down here. It goes from -16 to 15, with -17 being never kill. Question.
Since it's a runtime adjustment, in sysvinit, would you normally just set it in a init script? In systemd, I think this is something you can do.
Yeah, I am not sure on that one. Yeah, good question. I like your questions. I don't know the answer. I need to go look for it. So yeah, so it goes from -16 to 15. Again, to -17 being don't kill off. Okay. Obviously, with init being the exception of, well, you're dead then. It's fine. Let's see here. Real quick, take a look at that. Let's just grab another one here. Take a look at those scores. See PROC there, and say cat OM adjust and score. Okay, so the higher the number, the more likely it is to be killed off. That comparison to cat proc OM score adjust to SSH. Right. Being -17, and then try to kill it off. Please don't kill it off. If the box goes down, then fine. So. Okay, it does us no good to get an alert that we can't get on the box when you kill off SSH. Or you're out of memory and then you kill off SSH. So, question? Yes?
Yeah, what's the difference between score and adjust?
So the difference between score and adjust, let me bring the slide back up here real quick. So the score is what the OS deems its score to be, right? So the kernel. The adjust is your kind of influence on it. Say, you know, I know that it right now score is a -17 or score is a 1. Take 10 from that, make it a -9, right? You're kind of giving your input into it. Much like the nice and priority, you cannot determine the priority of a process, but you can say it's nicer or take away from that as root. Make sense?
Yeah.
Cool. Awesome. Question, you do first and then.
Oh, it said -16 to 15?
Yeah.
What is -17?
-17 is do not kill.
Oh, do not.
Yeah.
Okay.
That's a special case of do not kill.
Okay.
Question?
The man page points out that the file is deprecated in favor of out of memory _score_adjust.
When was that done?
Huh?
When was that done?
2636.
Okay. All right.
A while ago.
Yeah, a little bit ago. Well, for our environment, that's
It's working.
still.
It's working.
Yeah.
Not
So,
rude.
well, thank you. Appreciate that. So, questions? Cool. All right. Interacting with PROC. Okay, so I mentioned up to now we've talked about just getting information out of PROC, right? We haven't talked too much, except for the last example, putting information into PROC, right? Kind of tuning it a bit. I will say as a caveat, as a default caveat, that the defaults are usually pretty good for most workloads. Very rarely do we find ourselves having to change these values. Every once in a while we do. And so we'll go through some of those things. Real quick, you've probably seen me do this a couple times, but if you want to work with PROC, one of the first things you got to do is be able to get the PID or the process ID of a process. A couple ways we can do that. You've seen me do one for sure with this PID of HTTPD. Gives me all the processes or all the PIDs for that are associated with that HTTP process. Other one you can do is pgrep and say maybe for root. Let's see here, which will give me just the processes or the PIDs that are from the user root and associated with the Apache process. Okay. I'm doing a talk tomorrow where that becomes super helpful in doing some troubleshooting. So, and then a couple other things here. Talk about this for a second here. Cat proc self command line. So there is an alias to proc self, which is the currently running process, whatever process that is. Okay. So if I do that, what do I got? I have that cat process. Right. It's that simple. If we can actually look at proc, we'll see that self points to a PID. Okay. And that's just per process. It kind of just simply there. Just a reference itself. Okay. In case you're writing script, you're trying to write a process, and you know what your PID is, or you want to work with your own environment. That's a way to do it. Easy way to do it. Okay. Cat proc self. All the self. All right, and then if you're writing bash variables, right, the double $sign will give you your PID as well. All right, so of the process, the PID of the process that's running it, so that bash process, right? And if I could actually do cat proc $sign. Nope. I thought it was gonna be. There it goes. Yeah. It auto expands it out to the actual PID after that slash. So you know what it is. Cool. Okay. Just trying to make sure I'm not going over time. Okay. Let's see here. All right, tuning kernel parameters. So up until this point, like I said, we've only been doing is getting data out. Under proc sys, that exposes out all of the kernel tunables that we can modify. You know, those knobs we can twist and turn and have different effects on the system. Again, with the warning that, you know, turning something one way, you're having an effect on something else the other way. Or with anything you turn, anything you tune, you're trying to tune towards a certain workload. You're not trying to tune towards, you know, there's no only benefits, right? There's always another side to tuning. All right. So real quick, the kind of first command is sysctl-a to kind of get an idea of what we have. Again, I'll do it on the command line. Real quick, let's do this here. To get an idea of how many options there are. That's quite a bit, right? Again, do I know most of these? Hell no. Even some of them? No, not even close. Handful? Probably, right? You know, from this part on, you know what you've used it for, why you need to use it. But past that, you know, there's not a lot of people doing a ton of leisurely research, I would say, on this. And if there are, I'd love to talk to you because I want to know more. So, all right, we'll take this off here and kind of go through. All right, kind of just what we have here. Now, notice the formatting of these, right? Most of them are starting with, you know, a certain word and then have the certain path to it, right? So these, for example, here, let's pick one that's going to be interesting. There we go. I like this one here. VM overcommit ratio. Okay, so notice that path there, right? VM.overcommit.ratio. So if we go into slash, go away, there we go. Proc sys. We now have VM there, right? Let's actually go CD first. All right. Where'd it go? I have it under overcommit ratio. Okay. So here we should have overcommit ratio. Okay. Oh, no, there we go. I picked this one because it's one I've used in the past before to kind of keep a box up and running. The overcommit ratio says that how much memory the box will overcommit when trying to malloc memory out. Okay? You can set the 0 and it says, hey, if I got 4 gigs, never try to allocate more than 4 gigs. Okay. You can say, hey, at this point here, if I got 4 gigs, you can probably go to 6. Maybe it's mallocating but not using it, right? So it's again, it's one of those numbers that's funny. It's fuzzy to change, and you're only doing it in kind of very need to do situations, but it's out there for you. There's a ton of things out there like that for you. Okay. Some of the more common ones you can actually find in etsy.sysctl.conf. So here's where we find a few more that are a bit more common and at least documented on what they're doing. Like I said earlier, the stuff in PROC sys, it's hard to find documentation on what actually the values are. There was one, I'm trying to remember what it was. I think it was number of open files. But the max ended up being the number, what was it? For a terabyte, I guess, or a gigabyte. But that was that number was the max for that file. I couldn't find it anywhere, but I just kept upping it one by one and found a value that said no, can't take it. So here you find again, some of the more common ones. Let's see here. Oh, go away. That's not what I want. There you go. For example, here, swappiness, how aggressive your machine is about moving things in and out of swap or paging things in and out from disk. And then also, another one I threw down here for you is basically to ignore all pings, right? Now, changing these values is a certain process, or I take a certain process to it at least. Let's see here. All right. Okay. So I could do this process. I could do this process in one of two ways. I could echo out the value into proc sys net, such and such, or I can add it to sysctl.conf and reboot. I have seen people do both. I think one way is a bit more favorable because if you do something like this, and for some reason it's wrong or brings your box down, a reboot will save you, not persistent. Right? That's why I always tell techs to go that path first, watch it for a bit, make sure you didn't bring your box down, then make it persistent if it needs to be. Some of these things don't need to be. Some things are just temporary. Right? You're just trying to change at a very core level what's going on with your system. All right.
Question.
Yes?
When you change syscontrol.conf, does that change take place immediately?
It does not, no.
Okay.
Yeah, so that's why I've seen techs do that, change it. The question is if you change sysctl.conf, does it take change immediately? And no, it doesn't. If you did a -p, I think it is, I forget, because I try not to do it ever. sysctl-p, I believe it is. It will read the config file and put it in place. Let me double check that.
Is immediate.
Yeah, ESP. Okay. But otherwise, not immediately. And I always try to avoid doing it immediately out from that file, just because again, if I mess something up and reboot the box, it's in effect again, right? And then I have to go into rescue mode and try to recover my mistake again. So I always try to do via like UET echo into it, and you can change the value. If it's the same value that doesn't work, it'll tell you or it'll deny that change. If it's a valid value or a valid value, they don't keep it there. But if it borks the box, reboot and you're fine. Right? Again, that's just a bit of a process. That's all it is. From seeing people do it both ways and one really not working very well. So, all right. Any other questions, thoughts? No. All right, cool. Extras. Okay. How much time I got? 2:15 to 3:15. Oh my God, 60 minutes. Okay, cool. I want to do a couple things here. So, part of what really got me going for this talk on PROC was number one, seeing techs who didn't have a good, deep understanding of it. I'm not saying that I do. I'm saying that I want people to have an understanding of how to learn more about it, right? How to say, okay, well, I know some things. I know what I can change. I know what I can't change. I know where to look for things. I know where to find documentation and have a better tool set to figure things out. And that came from a talk that I'm actually doing tomorrow on strace. One of the examples I do in that talk is strace W. Right? For those not familiar, strace basically just interrupts the process and tells me what that process is doing and every single call that it does. Okay, so real quick, something like that. Okay, not pretty to look at, but we can break it down later on. But what I care about here is for a command simple like W, let's do here. What I'm telling strace to do right now is only give me system calls that have to do with opens. Okay. for a simple command like W, how much is pulling from proc to give me information? Okay, and I can do this for most of the tools I use every day and see just how much is being pulled from proc, right? That's what I want to make to a lot of tech to say that these tools that you have are just reading from the basic interface to the kernel. Nothing fancy, nothing crazy, okay? Even something like, what's another one I can think of here? strace vmstat. Okay. Right, we can get, maybe actually do the same thing. trace equals open. And we see what files we're actually reading from, right? And for those not familiar with vmstat basically pulls out VM statistics. If I do it once, it tells me that the box is up and running. If I give it a interval, one, there you go. First one is since the box has been running. The next one is since the last read. It's doing by reading proc over and over and over because it's real time to the kernel, right? So it can do that. Okay. Absolutely indispensable when trying to troubleshoot a box that's just not acting the way it should, right? And it's these tool sets like vmstat, iostat that we use when we don't have some of the the new relics or the app dynamics to really figure out what's going on in a box. No iostat really? Live demos, people. vmstat back that. Okay. So really, I want to show that is using strace to really dig deeper into. That's what kind of led me towards trying to do this talk and say, hey, there's so much you get out of there that most people don't even know about. If we go into / right here, procnet, right? Let's see here, TCP. While that is, I forget the base on that. It's not octal. It's I forget the base on it right now. But essentially, that's telling you what we get from not SS, ifconfig for the most part. Oh, sorry, IPA. Try and up and down the new commands. A lot of information comes from there, or actually not that. Sorry, ports. Right, what ports are open listening? What was the other one?
PCI.
Is that
PCI?
LSPCI? LSPCI?
No. Well, yeah, you could do LSPCI, but PROC cat PROC PCI.
So cat proc it moved somewhere. It moved. No, cat. I know talking about, but it moved somewhere in the last. I just looked it up too today.
Oh, did you?
Yeah, because I same thing. I was like, where is proc PCI?
Yeah.
Because essentially. Well, you know what? Let's try this out. I forgot where it is. strace lspci. And we do, again, -e, trace equals open, because I know it's got to be a file. Sysbus. No, not sysbus. Where is it? Where's proc? I guess it's pulling sysbus.
PCI devices.
Yep. Yeah, they moved some stuff into sys. Not recently, but you have to understand that a lot of our environment is still everything from Rails 5 and 6 and 7 to the occasional Rail 2 box we find out there running. So there's all over the board. That box never dies, so it's still up and running. But yeah, LSPCI pulls from sysbus, and now we can see that. Right? So that's kind of cool. Right, cat proc. What I do all the time is cat proc mounts. Right? That's the mtab. All right. The mtab being what's currently mounted, reading from proc what's currently mounted. It's helpful when NFS is acting up, and I think it's there. I think it's not. Question.
So, like IP tables, is that pulling data from this as well? I mean, kind of
Net filter? Yep. So I haven't looked too much into it, but I do know there is procnet. Where to go? Net filter. Now I can't tell you past. There's probably some other places too for it, but I couldn't tell you past that if it's somewhere in there. Might be part of the module as well. I'm missing somewhere in there. So.
There's a IP contract somewhere which is useful.
Yeah. Sure. Okay, there's a ton of things in there that, like I said, I'm not considering myself an expert at all. Just someone who's tried to do a little bit more research and share, right? And share. So, with that being said, I think I'm running up on time a little bit. So in closing, that's my contact information. If you have any questions or concerns, critiques, or anything else, that slide up there. Yeah, I'll leave up everything.
I'll give a critique. If you have fancy hardware like fancy RAID controllers and whatnot, be careful what you're poking around with because it'll reboot.
There was a story. It was actually last year. Let me get these slides. I'll tell you the story from last year. From Birds of a Feather. Real quick bio because my friend wrote it. And I told her I put it online. So she's down there. That's a bio. So Q&A, talk about whiskey, or I'm gonna tell you a story about that. It was actually last year at LinuxFest Northwest from Texas. We did a Birds of a Feather and basically a share war stories, right? And the dude that had a war story there was one he had heard from a previous conference, and it's a Google a guy working at Google, testing out shutting off RAID controllers or shutting off drives in a RAID controller on the machines. And so he tested it on 10% of his hardware. Great. Tested it on 50% of the hardware. Great. Everything worked great. He goes to almost all of his hardware. Great. Okay, this should be good. Tested it on 1% of Google's hardware. Perfect. 10, 15. You remember, it was not much higher than that. It was like 50%, 15%. Great. Release it out there. The model of the RAID controller that they were using everywhere else had a bug. They would try to shut down one drive, it shut down the machine. So this automated script in apparently Google's environment is running out, shutting down machines because one bad drive has failed. So to shut down machines off, they send another script to go turn machines back on somehow. So the story that he tells us is that he has these scripts going through the environment, shutting boxes off because of a bad drive, and one trying to bring them back up. And so that basically brought Gmail down that day. So the lesson from the story was that no matter how bad your screw up is, you weren't on CNN bringing down Gmail that day. But yeah, I do agree. With hardware especially, Fusion I/O drives are fun for us. They are some fun pieces of great hardware, but finicky too. Question?
So there's also like /sys at the root.
Mm-hmm.
What's the relationship?
So /sys is for the hardware devices, right? So if we look at /sys, jump here real quick here. Right, so what I usually look at sys block, right? Sys block, I can tell maybe my block device is there, or sys.
Well, isn't that stuff in dev?
Let's see here, dev, go there. It's some other. It has a bit more other information there. I'm not sure if it's all in dev. There's some crossover, yeah.
Yeah. Okay.
Yeah. So usually I'm looking at sys block to determine what essentially this output sometimes goes out to be, right? For PCI.
Which hard drive failed?
What's that?
Which hard drive failed?
Yeah. Try and line them up to which PCI bus. Usually we have either Dell or HP hardware tell us a little closer, but those like that row 2 box hardware wise. Yeah, we're using that. Try to figure out what died. Cool. Any other questions? Sorry, question.
Yeah, doesn't /sys also vary wildly across kernels?
I do not know, to be honest with you. I'm not sure. So, does somebody else know? Does /sys, sorry, speaking to the thing, does /sys vary wildly across other kernels? Like, I have no idea. Yeah. So, cool. Question back there?
Do you have a favorite whiskey?
I do, actually, I do. Actually, just taken in Seattle 2 days ago. My favorite whiskey is Booker's Bourbon. So, but we can do Scotch, Rye, Irish, favorites on all those.
What kind are you drinking now?
In a little bit, I'm going to drink some bourbon. I've thought about it. One day they're going to let me just bring a shot glass right here and just keep it there the entire time. Like, thanks. 5 minutes. Cool. We got 5 more minutes. More whiskey questions. Or any other questions at all? I have 5 minutes, I guess. So. If not, that's all I got. Thank you.